Hi guys, it's Talha here again. So today we are going to start from where we left off yesterday, which I skipped the topic. I skipped piecewise functions. I skipped piecewise functions, and I also skipped the vertical line test, where you test whether whether the graph is of a function or is a graph of just a normal line. So vertical line test, and then we are going to discuss different types of functions. There are many types of functions which we are going to discuss. Alright, so let's get started. Let's first discuss what is piecewise function. So what is a piecewise function? For example, when we apply different formulas for the different domains of the function in a graph. So for example, the most common example of a piecewise function is an absolute function. So what's the graph of an absolute function? So let me just draw a rough graph of an absolute function. So this is 1, 2, 3, minus 1, 3, 3, minus 1. Sorry, 1, 2, 3. Alright. So the graph of the absolute function is like this. Because what is an absolute function? Absolute function is y or f of x equals absolute x. So when you input any negative integer or a positive integer, it always gives you a positive integer in result. So when you input a when you input a negative value of x or a positive value of x, it will always give you the positive output. So the way we can write in a piecewise form is y equals x when x is greater than 0 and greater than or equal to 0, and minus x when x is less than 0. So there are different pieces of this function. This is one piece and this is another piece of this function y, which is f of x. So that is why we call it piecewise function, because this is one piece of a graph, this is another piece. So there are two pieces of this function. That is why we call them piecewise function. Now how to graph them? How to graph a piecewise function? So for example, I have a piecewise function given f of x equals minus x when x is less than 0, same thing as this one. And then we have another function given that is x square, and where x and there's a condition given where x is greater than 0, greater than or equal to 0, and less than or equal to 2. So how are we going to graph this? Well, it's pretty simple. So here this is a graph, this is a graph. So uh, f of x equals minus x when x is less than 0. So the value of y is minus x when x is less than 0. So it's minus x when x is less than 0. So its graph is going to be like this. And then we have x square when x is greater than 0. So when x is greater than 0 and less than or equal to 2, so its graph is going to be like this. So this is 1, 1, this is 2, and this right here, this is 4. I mean, this is 4. So this is 2, 4, and this is 1, 1, 1, or you can elongate this line and you can put as many points as you can. But right here, the way we graph this function is we look at the condition. So this right here is going to be the x value, the first x coordinate, and you put this x coordinate into this. this function of y. So what it outputs will be your first x and y coordinate, which is 0 and 0, and then you take the second part of the condition, that is 2, and you input that into the function of x. So that will give you 2 whole square equals 4. So your next coordinates will be 2, 4, and so on. So your first coordinate was 0, 0, and your second coordinate was 2, 4. So this graph is what it was, like this. And then you had minus x, so x is less than 0. So you can create a table if you want. You can plot as many domain range points as you want, but I'm just doing it directly. So x is less than 0, so you can put any value of x that is less than 0. So for example, I put minus 1 into this, so minus into minus 1, that will give me uh, minus 1. So here x is minus 1, no, sorry, x is minus 1, and when I put x minus 1 into minus x, minus into minus, that will make it plus 1. So that here x is minus, here is minus 1, and the y is positive 1. So that was how you graph piecewise function. Now let's see how to do the opposite thing, how to look at the graph and make a function out of it. So for example, I have a graph. uh, I have a graph 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. I have minus 1, minus 2, minus 3, minus 4. Okay, all right. So I have a graph, for example, I have a graph like this, and then I have a graph like this. All right, so this point is 2, 3. This is 2, 0. This is 0, 2, and this is 4, 0. Right. So it's a little it's a little tricky, but you'll get to it. It's pretty easy when you know how to do it. So let's first find the slope of this line. So what is going to be the slope? The formula is m equals y2 minus y1 equals x2 minus x1. Is pretty simple. All right, so let's plot the points. First, let's find the function of this piece. So let's plot the points. We have y2. Okay, let's consider this as x2 y2 and this x1 y1. So this here y2 is our 0 minus 2, and then x2 is our 2 minus 0. So that gives us m equals minus 2 divided by 2 equals minus 1. So the slope is minus 1. Let's put this the slope and the let's plot the points, and let's put the points in a point slope form. That is or the line of a equation, maybe. Yep. So y equals mx plus c, or you can do it this way: y minus y1 equals m x2 minus x1. So y minus y1, y minus 2, y minus 2 equals m x2. x2 is 2 minus 0. Yep. x2 minus x1, yes, x2 minus 0. So that is going to give me y, and m is our m is minus 1. So y minus 2 equals minus 1 into 2. That gives me y minus 2 equals minus 2, and that gives me y equals minus 2 plus 2. That gives me y equals 0. So right, so what you do is you put yes, so what you do, you put y equals 0. Okay, so f of x equals y equals 0. So this is the equation of y. This is going to be the function of y. Y equals 0, and the condition. So what's the condition? The condition is x. Okay, so if a line is like this, alright, so then an open interval means that the number itself is not included. Open interval means the number itself is not included. But when there is a closed interval like this means that the number itself is included. So here if we see, okay, let me just create the intervals. So this means that 2 is not included. So we can write as x is so here it is 0, coordinate is 0, so we can write as x is greater than 0 because it's not included, and then x is less than or equal to 2 because 2 is included. Now let's find an equation for this. Let's first find the slope. So m equals 4 0 minus 3 divided by 4 minus 2 equals minus 3 divided by minus 2. That gives you m equals 3 by 2. So, and let's put it into point slope form. So y minus what is y1, where our y1 is 3, equals m is 3 by 2, x2 minus x1, our x2 is 4. Yep, our x2 is 4, and minus 2, our x1 is 2. Yep, minus 2, so y minus 3 equals 3 by 2, 4 minus 2 equals 2. So y minus 3 equals 3 by 2, 3 into 2 6 by 2, 6 by 2 will be 3, and yes, 6 by 2 will be 3, and minus 3 and plus 3, so y will be 6. So here this is going to be the function of x. We are going to put 6, y equals 6, and then now we'll look at the condition. So here 2 is not included because it is an open interval. Here we're finding the piecewise function of this line, so consider this one. So here 2 is not included, so x is greater than 2, and 4 is included, so it's less than or equal to 4. So this was how you graph a piecewise function. You first find the slope of the line. For example, if a line is like this, we already know that y equals 4 because it's the intercept of y is 4. So y is going to be 4, and its slope is going to be 0 because the line is horizontal. But here in this case, where it has slope, where the lines have slope, you'll have to find the slope first. Then you're going to find the slope. You're going to put the slope and the points x, y in the point slope form, and then you are going to put and what you get as a value of y, you're going to put that as a function of x, and then you're going to make the condition out of the graph. Alright, now let's discuss different types of functions. So we have many different types of functions. We have linear functions. So in linear functions we have f of x equals mx plus b. When a function is in this form, this means it's a linear function because the degree is 1. The degree of this function is 1, and that's why it is a linear function, and its domain is always minus infinity up to infinity. Alright, the next function is a power function. A power function. So what is a power function? A power function is where you have f of x equals x, the variable, and the constant as its power. So you have x, the exponent, and then you have a constant as its power. This is called power function. Exponential function is exponential function is its opposite. F of x equals a power x. So the variable is the exponent, and the constant is a constant value, and exponent is an exponent. So this is called a exponential function. Now we have a polynomial function. Polynomial. So what is a polynomial? Polynomial is where you have where you have the exponents of x in a whole number power. It cannot be 1 by x, because the power of x is negative. You always have to keep the power of the variable a whole number, so 0, 1, 2, 3, like this. So this is called a polynomial. So any polynomial, for example, we have f of x equals a of x square plus b of x plus c. So this is a polynomial function because the powers of x are in whole number, and also this is a polynomial function of degree 2. We have the degree is the highest power of x in a function. So this is the polynomial function of degree 2, and linear function is the polynomial function of degree 1. So in p of x, this polynomial function can also be written as a n of xn plus a n minus 1 adds xn minus 1 plus this plus a1x plus a0. So you can have a polynomial function of degree 3. You can have a degree of 4. You can have a degree of 4, like this. So this was polynomial function. Now we have rational functions. So for rational functions, so for rational functions, we have f of x equals p of x divided by q of x. Any function in this form is going to be called a rational function, and in rational functions, q of x cannot be equal to 0, because anything divided by 0 is undefined. So that's why rational function cannot be equal to 0. Now we have algebraic functions. So algebraic functions are the functions which have algebraic operations involved with the polynomials. So this is also an algebraic function because it is a polynomial and it has algebraic expressions in it. For example, you can have square roots, you can have squares, you can have plus, minus, divide, and multiply. You can have algebraic operations with a polynomial that will be called as algebraic function. Trigonometric functions will be the function involving the trigonometric quantity. So you have sine, cosine, cos, etc. So f of x equals sine of x, like this. The functions like this will be called trigonometric functions, and the transcendental functions is your functions which are not algebraic. So you have trigonometric, you have inverse trigonometric, you have exponential, you have power. So, and also logarithmic function, which you have f of x equals log a of x. Any function in this form is going to be called the logarithmic function. Alright, I'm running out of time. Thank you guys. Thank you very much.